Today's lesson involves reviewing the rules for drawing a proper graph. So just copy these in your notes. We need to give a title. We're going to remember to indent as we write our axes and label and indicate units. And a reminder that on the x-axis, we always put the manipulated or independent variable. And we can remember that with a mnemonic mix, M for manipulated, I for independent on the x-axis. Continuing, we want to put the dependent variable or the responding variable on the y. Again, we have a mnemonic for that. Dependent, responding on y, the word dry. We want to choose appropriate and convenient scale, so we need to look at the whole range of data when we decide how to mark our x and y axes. We'll locate our points, and then we're going to draw the best fit curve or straight line for our data. We are not connecting the dots. So for our first example, and this you just need to look at, we will be going through this in class tomorrow, so just observe and take note of how we go about finding the different parts of the equation. An inverse proportion, we'll see a curve that looks like a C, and it will fit the general equation of y equals k over x, where k is a constant with units. And if we plotted y versus 1 over x rather than y versus x, we would see a straight line. So let's look at an example. We have data for a time versus speed graph. And when we plot the points, we see that it looks like a C, fitting the equation y equals k over x. So we want to find the equation for this example. Substituting for y, time, and for x, speed, we now only need to find our k. We're going to select 2 points on the line, and we want to select 2 points that are not data points, as some data points may not fall exactly on this curve. So 8.75 and 12 and 16.25 and 6 are points I selected. Now if I rearrange the equation y equals k over x for k, we simply find that it is taking the value of x times y for our coordinates. So for our first point, if I want to find k, would take the 8.75 kilometers per hour. Important to remember that the x and y coordinates have units, times 12 hours. Doing our math, I get 105. Hours would cancel. Kilometers would be the unit. Similarly, taking our second point, 16.25 and 6 as our coordinates, plugging those in for k equals x times y, I would get 97.5 kilometers. I'm going to take the average of those two numbers, and I get 101 kilometers. My equation now would be time, substituting our y, k, the 101 kilometers we found, and instead of writing x, we put the variable found on the x-axis. So our final equation for this graph would be as shown. In a direct proportionality, we will see a straight line after plotting. the general equation y equals mx plus b, where m is our slope and b is the y-intercept. Looking at a plot showing an example of a direct proportion shown with the data for mass versus age here. Again, we would substitute mass for our y and age for x, as these are the variables shown on the y and x axes. So we need to find slope. I will select 2 points as shown. Again, do not take data points, take 2 other convenient points from the graph to calculate your slope. A reminder, slope is change in y over change in x. We must also remember to include the units. So for example here, slope would be 9 minus 4 kilograms for our change in y. Our change in x, 280 minus 40 units of days. Doing the math gives us a final value of a slope of 0.02 kilograms per day. We now need to find our y-intercept to plug in for the b. By extending the line to pass through the y-axis, we read the value from the graph for b as 3 kilograms. We are not doing any math to calculate the b. We are reading it directly from the graph. Now making all the substitutions in our equation, instead of writing y, we look on the y-axis and find mass. We write the slope that we calculated, including the units, 0.02 kilograms per day. For x, we look on the x-axis, it's the variable of age, and now we copy the y-intercept that we read directly from the graph, including the units that go with y. So our final equation would be, for this line, mass equals 0.02 kilograms per day times age plus 3 kilograms.